Hey guys, this is the adding polynomials worksheet. I think most of the classes actually got to this. I think it was first period that never had a chance to get through it due to testing and whatnot. So I just want to give you a real quick rundown on what adding polynomials looks like. Fairly simple, just like combining like terms. The parentheses that you see around the quadratic expressions, don't let that distract you. That's just really just grouping. Because if you remember when you were in elementary school, they would give you add-ins, and sometimes they would group the first two add-ins, and then they wanted to show you when they grouped the second and third add-ins that it really didn't change the sum. The grouping or parentheses really doesn't change anything in addition. So the same thing applies here with these quadratics. Don't let the parentheses distract you at all. So all we're going to do very simply is identify our like terms. So in the first quadratic, we see 2m squared. The 2 is raised in the variable of m, which is like his friend over here on the other side, 5m squared. I'm going to color code the like terms. Then we have 3m with no exponent. And we have 7m on the other side that looks just like him. Then we have the constants that are remaining, which are 4 and 1. So now we just put those together. So 2m squared and 5m squared, when combined, make 7m squared. And 3m and 7m, when combined together, make 7m. And then when we put our constants together, 4 and 1, we end up with 5. And there's your answer to letter A on the worksheet. So the second part that you see here, location A and B, is letter B on the worksheet. What they're asking you to do is to find the total cost of the two locations. So basically what you're doing is adding the like terms again. So we're looking for the total, we're going to combine. So this one has fractions, so it's a little bit different than the other, but it's not really any different other than having to find common denominators. So in location A, we have 1/4 c squared, and his friend in location B would be 4c squared. And then notice that the negative 2/3 c doesn't have any friends, so he's just going to stay the same as he is. And then our constant from location A would be 5, and our constant in location B would be negative 5/2. Okay, so having to find like terms without a calculator. So here we go. We have 1/4, and we have 4/1, which is the same thing as 4. Our common denominator is going to be 4, and 1 times 4 is 4, so 4 times 4 is 16. And this one's going to stay the same because 4 times 1 is 4, and 1 times 1 is 1. So when I put these together, my denominator stays the same at 4, and 1 plus 16 is going to be 17. So we have 17 over 4c squared. Again, this stays because he doesn't have any friends. And so now we have to take 5 and subtract 5/2. I know many of you prefer to turn everything into decimals, and that's fine. But I'm going to go ahead and keep them as fractions. So if I have 5/1 and I subtract 5/2, my common denominator is 2. So he stays at 5. 1 times 2 is 2, and 5 times 2 is 10. And so what I'm left with is 5/2. And this is my answer right here. A little bit more work because there's fractions involved. And again, I know most of you like to turn everything into decimals and work from there. You should get the same answer either way. But just once you get your decimals, make sure you convert it back to the improper fractions, because that's what the answer choices look like. Okay, hopefully that helps.